Okay, let's start the third module and the second part of this third module. Free undamped single degree of freedom vibrating system. Okay. Now, what is meant by free undamped single degree of freedom vibrating system? Now, what is meant by free vibration? Anyone? Free vibration means what? Hello. Am I audible? Wait, what is meant by free vibration? Mukul? Either force applied or not applied. Mohammed? Atharva? Anyone tell me what is meant by free vibration, undamped vibration? These are the different types of vibrations. Free vibration means? Aditya?
Yes, sir.
Huh?
External force नसतो त्यात ना sir.
Okay, means once the body is displaced from its equilibrium position and release that force, it get vibrate itself because of its natural frequency. Okay, now this is known as a free vibration, and undamped means there is no resisting force to absorb the energy of vibrating system. Okay, now it is known as undamped means वहाँ पे damper नहीं रहेगा, and single degree of freedom means there is only one parameter required to define the position of the vibrating system or the motion of the vibrating system. It is a single degree of freedom. Okay, now these are the definitions of this free vibration, undamped vibration, single degree of vibration. Okay, now see the various points covered in this module. First of all, we will see the introduction. In introduction, we will see the what is meant by free vibration, what is meant by undamped vibration, what is meant by single degree of freedom vibration. Now, how to determine the natural frequency, the next point. Now, there are various methods used to find out the natural frequency. For that, you have to make a equation of motion. You have given the vibrating system. Now, you have to make a equation of motion to find out the natural frequency. Now, there are four methods we will see. Now, next is from that first method is your equilibrium method, or you can say D'Alembert's principle. Next is the energy method, Rayleigh's method. Okay. And last one is the torsional stiffness. Now, what is meant by torsional stiffness? These are the various points covered in this topic. And lastly, we will see the numericals to find out the natural frequency of the vibrating system. Okay. Free vibration means if the external force is removed after given initial displacement. Now, we have to give the first initial displacement and displace the body from its equilibrium position and to get vibrate itself. Now, this is known as because of the elastic nature of that body, it get vibrate itself. It is known as a free vibration. And undamped vibration means if there is no external resistance to the vibrating system to bring the body into the equilibrium position. And such vibrations are known as undamped vibration. And last is a single degree of freedom vibration. Okay. A single degree में क्या रहेगा? Only one parameter is required to define the motion of the vibrating system, and that parameter is either linear x1 or angular रहेगा तो theta. If the motion is linear, then you can say it is a x1. And if it is angular, now you can denote it by this angular motion by theta. Like this. Okay. Now here, there are various methods are used to find out the natural frequency of the vibrating system. Now that methods are used to obtain the equation of motion. Now first of all, we have to find out the equation of motion of the given system. If you have given the one of the system vibrating system, or you have given the simple pendulum, okay, means the weight is attached at the end of the string, and you have to find out the natural frequency of that system. First of all, you have to make a equation of motion for that given system. Now you have to find out once you get the equation of motion, you have to compare that equation of motion with the equation of motion. Now we know the equation of simple harmonic motion. Now what is the equation? Anyone? What is the equation of simple harmonic motion? लास्ट लेक्चर देखा था, x डबल डॉट प्लस ओमेगा square into x is equal to 0. If the motion is linear, if the motion is angular, you can write down instead of x double dot, you have to write down the theta double dot plus omega square into theta is equal to 0. X denotes the linear motion, theta denotes the angular motion. Now x double dot means what? Anyone? X double dot or theta double dot. What is x double dot indicates?
X double dot.
X acceleration, x double dot, and theta double dot is your angular acceleration. Okay, now x is a linear displacement, theta is the angular displacement. Omega is a angular displacement of that, or angular velocity of that body. Okay, now you have to find out the natural frequency, or you have to obtain the equation of motion for the given vibrating system. There are 4 methods. Okay, first is the equilibrium method. All of you know the D'Alembert's principle. Then energy method, you can use here law of conservation of energy, equation of the principle. And Relic's method, and lastly the Lagrange's method. Now this Lagrange's method is not in your syllabus. You have to refer these 3. You can use any one method from these 3. Out of these 3, you have to use any one method to find out the equation of motion of the given vibrating system. And you have to find out the natural frequency. Okay, we will see all these 3 methods. Now, basic of these 3 methods, you have to select any one method to find out the natural frequency. Okay, I suggest the energy method. Now, it is a very simple method to find out the equation of motion and the natural frequency of the given system. The exam में क्या रहेगा? You are given the one numerical. You are given the system, vibrating system. Now you have to find out the natural frequency of that system. You can use any one method. ऐसा नहीं कि तीनों method apply करना. You can use any one. What it all of you? Can you understand? Dhanasri? Mehul?
Yes, sir.
Now we see the first method is a equilibrium method or D'Alembert's principle. Anyone tell me what is this D'Alembert's principle? What is this D'Alembert's principle? Okay. D'Alembert's principle क्या है? If the body is displaced from its equilibrium position, okay, मैंने displace किया body linearly or angularly. I have to bring that body into the equilibrium position. The imaginary force act on that body. Okay, now that force bring the body into the equilibrium position. Now this is known as the inertia force. Otherwise, imaginary torque is required. Now this is known as a inertia torque. Now this is the D'Alembert's principle. Okay, now you have to, according to the D'Alembert's principle, body which is not in static equilibrium means you have to first of all displace that body and can be brought to the equilibrium position by introducing the inertia force. Now the magnitude of inertia force or external force are same but opposite in direction. Okay. Now when the body is displaced linearly, you can use the inertia force. If it is displaced angularly, you can use here. You can use here. क्या यूज करना है? Torque or couple. Okay. Now what this D'Alembert's principle says, the algebraic sum of the inertia forces and all external forces acting on the system must be equal to 0. So we can write down here the equation. The summation of inertia force which is required to bring the body into the equilibrium position plus external force is equal to 0. Now this is a very simple method. क्या करना है आपको? If you have given the system, vibrating system, you have to displace that system, or you have to give the initial displacement either angular or linear. Okay. Now I have to see the forces acting on that system. Now see the external force which you have applied on it to displace the body. Okay. And next is the inertia force. Otherwise, the restoring force you have to find out, and you have to put these equations into this equation. Okay, you have to simplify this equation. You will get the equation of motion. Okay. Now take down the one of the example. See here. Okay, I will explain here. Now see here. Now this is the spring which is suspended vertically. See here. Its thickness is K. Thickness is denoted by K. Okay. Now suppose to add the weight at the end of this spring. What happened? Anyone? We put the weight at the end of the spring. क्या हो जाएगा? If we put the weight at the end of the spring, now the spring get compressed, compressed or deflected.
Extend.
Extend हो जाएगा. Okay. Now the deflection of that spring is your delta. Now this is the initial deflection of the spring due to the weight. Okay. Now that position is known as a mean position. You can say equilibrium position. Now this is your mean position of the vibrating system. Stiffness is K, mass M. If you draw the free body diagram of this mass and show the various forces acting on that body. Now tell me the various forces acting on that body. Which are the forces acting on that body? कौन सा force act होगा? One force act due to the spring. Now that force moves up or down. Spring क्या करेगा? Pull करेगा या push करेगा? Anyone? One force act on that body is your spring force. Okay, either that spring push the mass downward direction or pull the mass upward direction. क्या होगा? That force act in upward or
करेगा.
so यहाँ पे pull करेगा यहाँ ऊपर. That force is your spring force. Now, what is the magnitude of spring force? Anyone? Spring force कैसे निकालते हैं? F is equal to CR. यहाँ पे लिखा है F. Sorry, K. Stiffness is equal to what? Stiffness is equal to force per unit deflection. Force upon deflection. Now, in that case, deflection is your delta. Force क्या आएगा यहाँ पे? Force is equal to K delta. Am I right? K delta. Is it right? Spring force is your K delta acting in upward direction. Next is a gravitational force acting downward direction due to the weight mg. Due to the weight mg. Okay. This we will write here. Suppose to resolve the forces vertically, you will get the equation K delta minus mg. Okay, you can see when the force act upward direction, take down the positive, and when the force act downward direction, you have to take down the negative. Minus 0, or you can write down here K delta is equal to mg. Am I right? Mg.
Yes, sir.
Is it right? Means at the initial or at the mean position, when we add the mass at the end of the spring get deflected at a delta distance. At the same time, the gravitational force act on the body is your mg. And the spring force and the gravitational force are same in that case. Okay, and you have to consider mean position. Mean position consider when the weight is added at the end of the spring is the mean position. Okay, now after that you have to apply the force and you have to deflect the body from the mean position. Now you have to apply here the force. मैं force apply करूँगा अभी. Body get deflected from its mean position. Mass is deflected from its mean position. Now this is your mean position, and the deflection due to the external force. Deflection due to the external force is denoted by x. Okay, now you have to apply here the force F. You have to apply here the force F, and you have to release it because it is a free vibration. Release कर दिया, but it is a extend position. When we apply the force at the end of the mass, now this third diagram is your extreme position. Okay, after that, you have to release the force, it get vibrate up and down. But the deflection x is a deflection due to the force vibrating. Okay, and that case stiffness is K. Now draw the free body diagram of mass. Now tell me the various forces acting on this mass. Anyone? Spring force act in upward direction, but its magnitude get changed here. What is the magnitude of spring force here? Okay. Into bracket, deflection due to the weight delta plus this total deflection is here delta plus x. Is it right? Yes or no?
Yes, sir.
Hello. A into bracket delta plus x. Now one downward direction mg. Now one more force act on this body, which is known as a restoring force. Now that force acting upward or downward direction, and that force is known as, when the body is displaced from its equilibrium position, imaginary force act on that body. Now that force is known as an inertia force. Correct? In that case, inertia force act in which direction? Upward or downward direction? Inertia force act on that body. That force is upward or downward direction. Tell me fast. Now, what is the role of inertia force on inertia torque? To bring the body into the equilibrium position. Force कहाँ पे act होगा? Upward or downward? Hello.
Upward.
Upward.
Correct. Means आपका main position कहाँ पे ऊपर है? Means it will act in upward direction, and its magnitude is, now the motion is linear. Now magnitude of inertia force is your m into, what is the magnitude of inertia force? It is equal to the accelerating force. Accelerating force is your ma. Correct? Means m, instead of a acceleration you have to write down mx. Is it right? Now this is nothing but your inertia force. Okay. Now k into bracket delta plus x is your spring force and gravitation force. Hello? अरे यहाँ तक समझ में आया क्या?
mx.
हाँ. mx. What do you say?
x double dot है ना तो?
mx double dot. Means it is acceleration. Now inertia force is equal in magnitude but opposite in direction of accelerating force. Now accelerating force क्या रहता है? Mass into, जो भी rigid body रहेगा उसका mass into acceleration. m into a. Now instead of a you have to write down x double dot. It is nothing but your acceleration. Okay. Now what this DLMS principle says? Equilibrium method says the summation of
Sir, what break होतो है sir?
inertia force plus external force must be equal to 0. I will write here the short form of inertia force. Yep.
Sir, your voice is breaking.
Now this DLMS principle. Hello. Now check. Voice is clear. Hello. अभी आ रहा है ठीक से आवाज?
नहीं सर, ब्रेक
वेदांत?
होतो है.
ब्रेक होते हैं थोड़ा.
1 minute. Okay, now check. Hello. Hello. Vedant. Hello everyone. Now voice is clear. Varun.
Yes sir, yes sir.
Okay. Now here, according to this DLMS principle, the summation of inertia force, which is
Yes,
denoted by IF plus external force, is equal to 0. External force is equal to 0. Okay. Now see the figure. From this figure, you have to put the magnitude of inertia and external force. Now in that case, inertia force is your mx double dot. I'll put here mx double dot plus external force due to spring is your k into bracket delta plus x delta plus x Now mg goes downward direction. Put here minus sign. Mg is equal to 0. Okay, now this is the equation of motion. Now you have to simplify this equation. Simplify kya karna? You have to multiply by this k to this bracket. You will get here mx double dot plus k delta plus kx minus mg is equal to 0. Now which term get cancelled here in this equation? Which term get cancelled? Anyone? Hello? Which term get cancelled here? See the equation. See this equation. K delta is equal to mg, na? K delta is equal to mg means what happened here? Put here k delta is equal to mg means plus and minus means it get cancelled here. Correct? Means the equation become mx double dot plus kx is equal to 0. Or I will write this equation like this: x double dot are divided by this whole equation by this m is x double dot plus k by m x is equal to 0. X double dot plus k by m into x is equal to 0. Now this is the simplified equation of motion of the given vibrating system. Okay, now you have to compare this equation with the equation of simple harmonic motion. Now what is the equation of simple harmonic motion? SHM का equation क्या है? X double dot plus omega square, or you can say it is a natural frequency omega n square. X is equal to 0. If you compare these two equations, you will get here omega n square is equal. Omega n is a circular natural frequency of that vibrating body. Omega n square is equal to what? You will get here k by m. Am I right? Got it, all of you?
Yes, sir.
Omega n square is equal to k by m, or you can write omega n is equal to. I'll write here. Okay. Or you have to write down here omega n is equal to. क्या है omega n is equal to? Omega n is equal to under root of k by m. Now this is known as a circular natural frequency of the given vibrating system. K is the stiffness of the spring and m is the mass of that vibrating system. Okay. Now we know the frequency Fn. Okay. Now Fn is the frequency of that vibrating body, number of cycles per unit time, and omega n is nothing but your natural natural frequency of that vibrating body, circular frequency. I have to find out the Fn. Fn is equal to, Fn का formula क्या है? Omega divided by or omega n divided by 2 pi. Correct? Is it right? 2 pi. So you will get the frequency is equal to 1 upon 2 pi. Put the value of omega n here, k by m. K by m. Fn is equal to omega n upon 2 pi or is equal to 1 by 2 pi under root of k by m. Got it, all of you? Hello? Are you understand? Ajinkya?
Sir,
Neeraj?
FN म्हणजे frequency of
Frequency of that vibrating body, number of cycles per unit time. Okay, number of cycles per unit time. Okay, all of you note down this.
sir आणि
Write down.
n
Hello.
हा सर ओमेगा n ला काय बोलणार?
Omega n is a circular natural frequency. All of you note down. Omega n is a circular natural frequency of that vibrating body. Okay, and Fn is a number of cycles per unit time. frequency of that body?
So circular.
Natural frequency. Omega n is equal to circular natural frequency of vibrating body. Only write down the circular natural frequency. Okay, now Fn up to Fn you have to write down. Do it fast. Draw this figure by hand. Now first figure is your initial figure. Second is the equilibrium position. Third is the free body diagram. Fourth is extreme position. Last one is a free body diagram. Means equilibrium method में क्या करना है? So given the vibrating system और एक कौन सा भी system दिया रहेगा. Suppose simple pendulum is given. Okay. I have to give the small displacement to that pendulum. Okay. And after that, see the various forces acting on that pendulum. Now it moves in circular path, means the displacement is theta. In that case, inertial torque act on that body. Okay. Instead of force, you have to write down the inertial torque plus external torque is equal to 0. We'll see the numerical. That time you will get a clear idea. Okay, done, all of you. संग्राम हो गया? Hello, am I audible?
Screen is not visible, sir.
Huh? Screen is not
Screen is
visible.
not- Yes, sir.
हाँ, अथर्व.
Yes, sir. Screen is not visible.
Okay, 1 minute. Okay, now it is visible.
Yes, sir.
Should be. Okay, now here. Now this is your spring is suspended vertically in initial position. Second figure is your spring is in stand position. Now you can see it is a mean position. Third is a free body diagram of mean position. Now D figure is your displaced position. Means you have to act the force. You will get the extreme displacement of that mass. Okay, now the different position. Got it? Now the description is given here. What is meant by M? What is meant by K? What is meant by delta? Okay. Now delta क्या है? Deflection of the spring due to weight, and X is a displacement due to the applied force. Okay. Now this is the equation. You will get when the mass is attached at the end of the spring. You will get this equation number 1. Mg is equal to K delta. Okay. Now this is for the figure number 3. Mg is equal to K delta. Now next force is applied. You will get this free body diagram. Okay. Now where the various forces acting on the mass, the description is given here. inertia force mx double dot act in upward direction. Spring force, or you can see it is a restoring torque which act in upward direction, k into bracket x plus delta. Gravitational force act in downward direction, mg. Okay, and positive sign for upward direction and negative sign for downward direction. Then you have to write down the according to D'Alembert's principle, inertia force plus external force is equal to 0. In that case, inertia force is your mx double dot plus external force k into bracket x plus delta minus mg. Mg goes downward, that's why you have to write down here minus. Okay, I have to simplify this equation. Now k delta and mg get cancelled here. Okay, now write down up to this. Don't draw this description. Only write down the according to D'Alembert's principle and write down the equation. Do it fast. यहाँ तक हो गया सबका? Okay. See the next slide. K delta get cancel here. You will get here mx double dot plus kx is equal to 0. You have to divide it by this equation m x double dot plus k by mx is equal to 0. Now this is equation number 2, and this is the equation of motion of the given vibrating system. You have to compare this equation of motion with the equation of simple harmonic motion. X double dot is equal to omega n square x is equal to 0. Means omega n square is equal to, compare this to and third equation, you will get omega n square is equal to k by m, or omega n is equal to under root of k by m. Okay, omega n is your circular natural frequency. Omega n is nothing but your circular natural frequency. Okay. Next, natural frequency of vibrating system is your Fn is equal to omega n upon 2 pi. Or you have to write down Fn is equal to 1 upon 2 pi under root of k by m. Now under root of k by m is the equation of omega n. Now the frequency in terms of hertz. Okay, write down up to the equation number 4.
सर आणि थीटा डबल डॉट काय होतं स्टार्टिंगला?
मैं बताता हूँ थीटा डबल डॉट. If there is angular position, angular displacement अगर हो गया, now at that time you have to write down the theta double. Pendulum का numerical लेने वाले हैं, ठीक है? Now this is the simple pendulum. पास जाता है. I have to give the displacement here. Okay, at an angle theta. Theta is the angular displacement. Theta dot is the angular velocity. Theta double dot is your angular acceleration. Okay, now in that case, your inertia torque act in this direction. Its magnitude is I theta double dot. Okay, we'll see the numerical. That time I will explain this. Okay, now I will write down this up to this. Go to the first. Okay. Can we go for the next slide? Vedant. Okay, सबका. Aditya Raj.
Yes, sir.
Now Fn मिल गया यहाँ पे. Now we know the time mg is equal to k delta. Okay. mg is equal to k delta मुझे पता है. Means I will write here k by m is equal to. Find out here k by m. क्या मिल जाएगा यहाँ पे? K by m is equal to g by delta. Okay. Now instead of in frequency k by m, you have to put the value of g by delta. क्या आएगा यहाँ पे? Fn is equal to 1 upon 2 pi under root of g by delta. Okay. One time this derivation is asked for 5 marks. Derive an equation of frequency. Fn is equal to 1 upon 2 pi under root of g by delta. You can give the example of mass which is attached at the end of the spring. You have to derive this equation. Okay, or in some of the numericals, you have to solve the delta. You have to find out the delta. Okay, means deflection due to the gravitational force. That time you can use this equation. Okay, time period क्या रहेगा? Inverse of this frequency 1 upon Fn means 2 pi under root of delta by g or m by k. Okay, don't write this time period, or you can write on this. It is equal to time period is the inverse of frequency. Okay. So here I have given the note here. While writing equation of motion for any vibrating system, here for any vibrating system with the spring as a one element, उसमें spring as a one element होना चाहिए. Both gravitational force and spring force due to deflection, K delta get eliminated. Okay. While we are writing the equation of motion for any vibrating system, but there is a spring is a one element, both gravitational force means mg and the spring force K delta is eliminated. Okay, and you can see this is the simplified method of equilibrium or D-limit space. Now the mass is attached at the end of the spring. This is your mean position. Second, it is displaced from its equilibrium position. It is extreme position, and see this forces acting on this free body diagram. We eliminate here K delta and mg. There is no need to consider this K delta and mg. Directly write down the equation. यहाँ पे directly आ जाएगा. Inertia force plus external force is equal to 0. Inertia force क्या है मेरा mx double dot plus external is equal to kx is equal to 0. Okay, this x double dot plus k by mx is equal to. Got it? Since you have to solve the problem within 2 to 3 steps. Maximum 4 to 5 steps are required. Finish this derivation or the numerical for each and every problem. Okay, don't write this. Okay, all of you understand this equilibrium method? Is there any doubt? Rishikesh? Vishwesh? Priya? Ayush? Arbaz?
Yes, sir.
Equilibrium method में क्या करना है? You have to take down your original figure or original vibrating system. You have to give the displacement, either angular or linear displacement. Okay, it is mentioned in the numerical. After that, you have to find out the various forces acting on that system with the inertia force, and you have to put that forces into the equation of the element. And you have to simplify that equation. You will get the equation of motion. Now compare that equation of motion with the simple harmonic motion equation, and you have to write the constant frequency of the vibrating system. Okay, now see the next one is your energy method. Okay, now this is very simple method. We know there are two types of energies. First is kinetic energy, okay, and potential energy. Am I right? You can write down the total energy of the vibrating system. Now it is addition of kinetic energy plus potential energy is equal to 0. Is that clear? Hello? Kinetic energy is equal to 0. Now when the kinetic energy is maximum, when the body is at the mean position or equilibrium position, and potential energy is 0. When the potential energy is maximum, at extreme position it is maximum and kinetic energy is 0. Okay. Now you have to consider here the two system. You have to consider the spring mass system again same. This deflection is your x. A is the spring stiffness, and here is the mass. Anyone tell me the kinetic energy of this vibrating system is equal to what is the formula energy potential for the given system? And the kinetic energy is equal to 1/2. 1/2
mv square.
m x
MV square, sir. MV square.
m v. V means x dot. Am I right?
Yes, sir.
V is x dot.
X dot.
Square.
हाँ.
Potential energy क्या आएगा? Potential energy.
MGH.
1/2 mgh. If there is a displacement, and height is given, that time you have to use here the another formula mgh. Correct? The height of the
Yes, sir.
system from position is given, you can use this equation mgh, correct? But in this case, what is one spring is given? Energy is due to the displacement of height h and potential energy due to the elastic nature of the ball. What is the formula of that? Upon to k upon to kx square. Am I right? Now this is because of the elastic nature of that vibrating body, and you have to apply this for this equation when the displacement height is given mgh. Is it right? If there is no spring, अगर spring रहेगा तो potential energy क्या आएगा 1/2 kx square. Got it all of you?
Yes, sir.
समझ में आया? I have to put this into this equation. क्या आएगा यहाँ पे 1/2 mx dot square plus 1/2 kx square is equal to 0. Okay. Now I have to differentiate this equation. I will differentiate this equation. I will differentiate this equation. क्या आएगा? d by dt. Now what you will get here? यहाँ पे differentiation क्या आएगा? 1/2 into m is a constant. X dot is a velocity. Now you have to differentiate it. X square means 2 into x double dot. Differentiate velocity का differentiate किया तो acceleration आता है ध्यान में. X double dot x dot plus 1/2 k is a constant stiffness of the spring. K x square means 2 displacement का differentiate velocity x dot x is equal to 0. Is this equation correct? Now check this equation. Hello?
हॅलो सर.
Ah,
एक्स म्हणजे तो डिस्टन्स, एक्स डॉट म्हणजे वेलोसिटी आणि एक्स डबल डॉट म्हणजे ऍक्सेलरेशन का?
x double dot is the acceleration, x dot is the velocity and x is the displacement. Correct? यहाँ पे x dot है, उसको differentiate किया तो x double dot आएगा. Means velocity का acceleration. यहाँ पे x से displacement को differentiate किया तो velocity आएगा. Right? Now in this equation, which term get cancel? क्या क्या cancel होगा यहाँ पे? 2 get cancel both side. And one more thing, x dot. Is it right? So you will get here equation mx double dot plus kx is equal to 0. Or you have to write down x double dot plus k by m x is equal to 0. Now it is similar to the previous equation of motion of D'Alembert principle, correct? Is it right?
येस
Same
सर.
here, means you will get the same frequency. Fn is equal to, you will get the same. I will not write all the things. Fn is equal to 1/2 pi और omega n क्या आने वाला है यहाँ पे under root of k by m. So you will get the same equation of motion, same frequency by using the both the methods, D'Alembert's principle and energy method. Is it right? Okay. All of you note down this. Now you have to take down the example. Spring mass is attached at the end of the spring. Find out the kinetic energy and potential energy, and you have to differentiate it. You will get the equation of motion. Okay, done. आदित्य हो गया? Julie?
Yes, sir.
Now see here, first of all, mark your attendance. You don't mark proxy, only 52 are present here. All of you mark your attendance. Now here I will show you PPT. Now energy method. Energy method means you can use here the principle of conservation of energy. Means energy can neither be created nor be destroyed, but it can be converted from one form to another form. Now this equation or this law can be applied to develop the equation of motion of the vibrating system. Means in short form you have to write down total mechanical energy of the vibrating system is equal to kinetic energy plus potential energy. Okay, kinetic energy plus potential energy is equal to constant. Now, kinetic energy is due to the motion of that vibrating body. Means when your body is at equilibrium position, kinetic energy is maximum. When it is displaced from the equilibrium position, kinetic energy gets decreased and it is zero at the extreme position. Okay, but potential energy consists of two parts. First is a gravitational potential energy due to the position of the body with respect to mean position. If there is no spring and the body is displaced from its equilibrium position, now the height is given. For example, now this is the simple pendulum. You have to displace this body from its equilibrium position. Now this is the height. In that case, you have to use here potential energy is equal to mgh. Got it? Mgh. You have to find out this distance. Okay, because L is the length is given here. This angle theta is given. Okay, by using these terms, you have to find out the h. And next is due to the strain energy, or you can say spring. If there is a spring or the elastic nature of the body, you have to write down the potential energy is equal to 1/2 kx square. Kx. These are the two formulas. Now, kinetic energy का एक formula है 1/2 mx dot square. If linear motion, if there is a linear motion. Okay. Next, again, kinetic energy is maximum at the equilibrium position and potential energy is 0. And kinetic energy is 0 at extreme position, potential energy is maximum. Is according to the law of conservation of energy, you have to write down the total kinetic energy plus potential energy is equal to 0. Understand? Hello? All of you mark your attendance. Link will be closed within 2 minutes. Okay. I have to differentiate this equation. Means d upon dt kinetic energy plus potential energy is equal to constant. D upon dt into bracket kinetic energy plus potential energy is equal to 0. Now you have to write down the or take down the example of spring mass system. The kinetic energy क्या आएगा 1/2 mx dot square or m upon m v square. You can say it is the velocity x dot, and potential energy is due to the deflection of the spring is equal 1/2 kx square. Put these two equations in the equation number 1. Okay, and you have to differentiate it. You will get here 1/2 m to x dot x double dot plus 1/2 k to x dot. Again 2 get cancelled and x dot get cancelled. You will get here mx double dot plus kx, or you can take down the x dot common. You have to increase the one step. You will get here equation number 2 mx double dot plus kx is equal to 0. Okay. Again simplify this. You will get here x double dot plus k by mx is equal to 0. We know the fundamental equation of simple harmonic motion. X double dot plus omega n square x is equal to 0. Means omega n क्या आएगा मेरा under root of k by. Again same as the previous. This frequency क्या आएगा 1/2 pi under root of k by m, और time period क्या आएगा inverse of frequency. T is equal to 2 pi under root of m by k. Okay, are you understand all of you?
Yes, sir.
Okay, Now see here. Now this is the equation of energy method. Equation of energy method. And DLMBERT's का equation क्या रहेगा? Summation of inertia force plus external force is equal to 0. This is the DLMBERT. If we solve this same problem by using the both methods, you will get the same solution. Okay. Either you have to prefer the energy method or you have to prefer the DLMS principle. Okay. Whichever is easy for you, you can refer that method to solve the numerical. There any doubt? Hello?